Hello everyone. In this video we're going to be solving a number theory problem. We have n to the fourth power plus 4 equals p, where p is a prime number, and we're going to be finding the values of n. N is a positive integer in this case. So how do we solve these kinds of problems? We have two variables, but we have a single equation. So we're going to be using an identity to solve this problem, which is called Sophie Germain's identity. Sophie Germain is a French mathematician, and this identity is known by her name. So here's how it works. We have n to the fourth power plus 4, and we've done some other videos on this one. We can basically add something to both sides, like something like 4n squared, and then subtract 4n squared. Now you might be questioning, like, why did I do that? So here's the idea. N to the fourth power is n squared squared. And this is 2 squared, right? So we have two terms that look like a squared plus b squared, and I want to complete the square. So what I need to add is 2ab. But I can't just add it, I also have to subtract it to balance it out, because at the end they cancel out. Make sense? This becomes a perfect square. But the idea with the Sophie Germain's identity is to also get a perfect square here. With the 2, you don't always get it, but what if there's another 2 and b is a perfect square? Make sense? Okay, so here's what it's going to look like. This is n squared plus 2 squared, and this is 2n squared. Make sense? Now this is a difference of 2 squares. So we can go ahead and factor it. Remember, difference of 2 squares, a squared minus b squared, can be written as a plus b multiplied by a minus b. That's what we're going to use. So I'm going to write it as n squared plus 2 plus 2n, and then n squared plus 2 minus 2n. But I want to write these in standard form, so let's go ahead and write them in standard form. N squared plus 2n plus 2, and n squared minus 2n plus 2. So these are two quadratic polynomials, which are factors of n to the fourth power plus 4. And that's supposed to equal p, a prime number. Is this at all possible? First of all, prime numbers only have two factors themselves and 1. So in this case, how can this number have two factors if it's not factorable? Well, one of the factors can be 1, and in that case, it is going to be prime. So which one is going to be a 1? First of all, notice that n squared minus 2n plus 2 for positive integers is always less than n squared plus 2n plus 2. Well, we're going to look at both cases. How about starting with the first one? So what if this equals 1? From here we get n squared plus 2n plus 2 equals 1. And then we can go ahead and subtract 1 from both sides. And we get n squared plus 2n plus 1 equals 0. This gives us n plus 1 quantity squared equals 0. And at the end we get n equals negative 1. So can n equals negative 1 be a solution? Yes. If we're looking for integer solutions for n, negative 1 is okay. If we're looking for positive integers, it's not okay. So let's go ahead and look at the other case. So if this is 1, then this needs to be a p, right? And what is, we don't care about the p, but is that really going to be a prime number? Let's go ahead and check. If n is equal to negative 1, the second factor is n squared minus 2n plus 2. That is going to be 1 plus 2 plus 2, and that is going to be 5. Okay, great. And 5 is a prime number, so we're all good. How about the other case? N squared minus 2n plus 2 equals 1. In that case, we get n squared minus 2n plus 1 equals 0. This is n minus 1 quantity squared equals 0, which means n equals 1. And when you plug in n equals 1 into the other equation, you're going to get p equals 5 again. So in both cases, you get p equals 5. Why? Because if n is a solution, negative n is also a solution because of the fourth power. So yes, there is two solutions if you're looking for integers. For positive integers, there's only one solution for which n equals 1. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.